Hello, and welcome to the next video of our TIA Portal Introduction series. Just a short wrap-up of what we've done so far. We added the hardware configuration. We linked sensors and actuators with the hardware using a tag table. We wrote a simple program inside the main function block, OB1. This program defines how the PLC should behave. Process overview. Let's look at the system we've set up. Green pieces are placed at the start of a conveyor belt. Sensor B1 detects the piece. We press S1, the push button. The conveyor starts and moves the piece forward. Sensor B2 detects the component. The stopper opens briefly, but the conveyor remains active. Then the stopper closes. Finally, B3 detects the piece at the end and turns off the conveyor. The process completes, and the piece can be taken off the belt. This is a very simple example, ideal for beginners. Basic logic explanation. Our logic works like this. If a piece is detected and the button is pressed, we turn K1 on. Note, B3 sends a high signal if no component is present. If B3 is high, the reset will not trigger. If B3 is low, it means a piece is there and the reset will activate. B2 directly activates the stopper. This is known as a direct assignment. 4. Starting the simulation. Now, let's simulate the setup. In the project tree, select the highest level of the PLC hardware. Click Start Simulation at the top or right-click and choose it. This opens PLCSIM. There are two versions of PLCSIM, one for S7-1200 and S7-1500, one for S7-300, 400, and 200. We are focusing on the S7-1200 and 1500. PLCSIM needs to be downloaded separately. Use your regular TIA Portal license. No extra license is required. The download link is provided in the video description. 5. Simulation startup. After opening PLCSIM, hit OK if a pop-up asks to enable simulation. Your simulated PLC will now load. Once the download preview shows no errors, click Load. Your program will be downloaded into the simulation. Click Run to start the PLC. Monitoring the simulation, click Go Online to monitor the PLC. All green means the program is downloaded and matches. Click the glasses icon to enable monitoring. You'll see two line types. Blue dashed lines mean logic 0 or inactive. Solid green lines mean logic 1 or active. Let's understand the signal flow. B1 isn't active, so the current path is broken. B3 is a normally closed contact. When inactive, it allows logic to flow. We need to invert B3's behavior in the simulation. Expanded simulation view. Click the expanded mode icon to open the full view. Create a new simulation project. Name it simulation_YouTube. This will simulate your hardware configuration too. Now, open the device configuration. You'll see the I/O modules and toggle bits. Open a simulation table. Use the Load Project Tags button to auto-load all tag names from your PLC project. Manual signal simulation. To simulate the process manually, activate B3. To simulate that no part is present, activate B1. To place a component, click S1, the Start button, now. K1 turns on. The conveyor starts running. Deactivate B1 to simulate movement. K1 remains on because of the set latch. Activate B2. The stopper opens automatically due to direct assignment. Deactivate B2 to close the stopper. Activate B3 to detect the part at the end. The conveyor turns off via the reset logic. Using sequences for automation, PLCSIM also supports sequences to simulate behavior automatically. A sequence consists of a trigger and a series of actions. Our trigger, when K1 turns on. Set actions to occur every 5 seconds. I will now set the following sequence of actions. B1 equals false, B2 equals true, B2 equals false B, 3 equals false B, 3 equals true. These true and false values reflect how the process behaves in real life. After entering these actions, I will enable looping so that the sequence repeats continuously. To trigger the sequence, I will start by setting B1 to true. Then I will press S1, the start button. Now, watch the sequence in action. The conveyor starts running. B1 deactivates, B2 activates, and then deactivates. B3 activates, triggering the conveyor to stop. This simulates the entire process hands-free, just like in a real automated system. Conclusion: this was a basic introduction to simulating a Siemens PLC project using PLCSIM. We have created and downloaded logic, used tag tables to link inputs and outputs, simulated the process manually and through automated sequences. In the next video, we'll explore more advanced simulation techniques. We might also look into using PLCs from the 300 and 400 series. If you found this helpful, leave a like, subscribe to the channel, and drop your questions in the comments. Thanks for watching. See you in the next episode.